Bismillahirrahmanirrahim. Today I'm going to give you a lecture on Hinsberg test, that test which is used for the identification of amines. As you have an idea, the amines are basic compounds and frequently used for the preparation of azo-dyes. The students which work in the labs for the preparation of textile dyes, especially the azo dyes, they do utilize amines, especially the primary amines. However, if they are given different compounds as an amines and they are to find out whether that is a primary amine, secondary or tertiary amine, they are to distinguish between the three categories of the amines, then the Hinsberg test could help them to find out the exact nature of the amines, because they can use only primary amines for the diazotization that is very much needed for the preparation of azo dyes. As you know, the secondary and the tertiary amines, they don't give diazotization test for the preparation of azo dyes. So once you want to generate azo dye, or you just want to confirm the nature of the amine, primary, secondary, or tertiary, one can use Hinsberg test as an identification test. I can write it distinguishes what is Hinsberg test, why we perform it. It helps to identify, the nature of amines, that is primary amines or their secondary amines, or the given compound is some sort of a tertiary amine. So you can find out the given amine. Why Hinsberg test? I've explained in my last of the lecture that amines are basic compounds. You can confirm them by using three different confirmatory tests. In that very respective, I've given you a very comprehensive lecture about diazotization test. Diazotization test. This is the test number 1, you may say, for the identification of amines. Okay, for amines, one can use diazotization test, or one can use carbyl amine test. These two test has already been explained in my previous lectures as the confirmatory test for the identification of primary amines. I've explained the mechanisms, what actually happens inside the test tube, how the reagents react with the given amine, and how one can confirm whether the given compound is an amine, primary amine. Similarly, the carbyl amine could help you out. If you want to distinguish, or you don't have a reagents available for these compounds, you may go for the test number 3, that is also used for the identification of amine, that is Hinsberg test. Today I am to explain the chemistry of the Hinsberg test, what happens actually inside the test tube when you mix the Hinsberg reagent with the given amine, what appears to be for the confirmation of the primary amine, then what happens if the amine is secondary, and what will you observe inside the test tube if the given compound is a tertiary amine. So primary, secondary, tertiary amines will be observed inside the test tube as a result of the reaction of the given compound with the Hinsberg reagent. So what is the Hinsberg reagent? How it reacts with the amine? This is what I'm going to explain to you guys. That is actually the chemistry of the Hinsberg test. I may write it as the chemistry of Hinsberg test. It is called Hinsberg test after the name of the respected scientist, the Hinsberg, who introduced his Hinsberg reagent. You know what is Hinsberg reagent, which is used in this specific test, that is some sort of an aryl sulfonyl chloride. You know, this sort of the reagent is used during the Hinsberg test. It's an Hinsberg reagent. This compound actually reacts with the given amines, and then the subsequent product formation leads us to the identification of their degree, whether it's a first degree, second or third degree, mean primary, secondary, tertiary amines. So this is Hinsberg reagent. So it reacts with any given amine. That is it is how it is really. Let's say I can denote actually an amine like this way, a primary amine. Let's say if we have Hinsberg reagent, what happens between these two bodies? You know, we have an idea the amines carries lone pairs. This lone pair attacks at this sulfur, which is supposed to be a partially positive. Why it is partially positive? Because it is connected with 3 electronegative gentle leads. You know, the chloro is supposed to be electronegative. 2 oxygens are connected, they are also electronegative in nature. So they pull these electrons towards them, leaving sulfur with a sort of a partial positive charge, and this production or generation of partial positive charge provides a chance for the lone pair of the nitrogen to attack at this carbon, you know, at the sulfur atom. At the same time, we have an idea this chloro being electronegative in nature and a good leaving group leaves from here. So what happens? We will have a sort of a product. Here is the amine, the original, and its lone pair attacked with sulfur, so it will look like this one. Here are the oxygens. Here is the aryl unit. This chloro has left in the form of chloride. Now at this point of time, the nitrogen is supposed to carry positive charge due to the excess of valency, you know. So in order to neutralize the positive charge, this proton is removed. This proton is removed from here. So how it will settle down? It will look like R. Yes, this will be the resultant product plus HCl. You know, the proton from here and the chloro which has been moved, we will give you the HCl. So this is called a sulfonamide. This is called a sulfonamide. It is produced inside the test tube. Let's say you have put in and sort of an amine, and then you put in Hinsberg reagent, and you shake it well, let it for a while. Sometimes you need to heat a bit. Then this happens inside the tube, and this body is produced, which is a sort of a sulfonamide, and amide bond sulfonamide, you know. Depends upon what is the nature of the R group, whether it's some sort of a primary alkyne, a linear chain alkyl group or some sort of an aromatic ring is there, it's a sort of a no issue for the product. So what happens at that point of time when it forms? We introduce sodium hydroxide into the test tube. In the test tube, we put in the given amine, we put in the Hinsberg solution, Hinsberg reagent, and shake it and then let it stand for a while. As soon as this bud is produced, we put in sodium hydroxide. We have an idea. Sodium hydroxide is a strong base. It has the capacity to pull proton from any other a bit acidic species, At the moment, is sulfonamide. We have an idea. The bond between nitrogen and hydrogen, it becomes a little bit polar. Means it's a sort of an acidic proton. It's not that strong acid. It's not that strong, but this strong base has the ability, has the capacity to capture or to pull this proton out. So it pulls it out. It pulls it out from here. So what happens then? Resultantly, there will be a salt formation over here. Resulting salt formation will happen, and then salt will be soluble, Mean this compound becomes soluble in sodium hydroxide. As soon as we will put in sodium hydroxide, the salt produced in will become soluble. That solubilization will suggest the given compound was a primary amine, It's a primary amine. Why it happens so? Because it means it's a primary amine, means it would have carries two protons. One of the proton has been removed during the first process, during the first step, during the sulfonamide formation. The second available proton would have been extracted by the base. Then the salt would have been produced, and that salt would have become soluble, which suggests the given starting compound was a primary amine, So this is how this soluble salt formation suggests the starting compound was a sort of a primary amine. If it is not a primary, then what would have happened? So this is what has happened. If your starting compound is a primary amine, then it would have moved through the step number 1, generating the sulfonamide, and the balance of the one of the available proton would have resulted in the formation of a salt soluble in sodium hydroxide, to confirm the presence of primary amines. Let's look if the given compound is a sort of a secondary amine, then what would have happened then? Let's say if we have two R groups, then it will be a secondary amine. It's a secondary amine. Okay. I'm not talking about the nature of R's at the moment, whether they are sort of alkynes, linear chain groups, or they are some sort of an aromatics, or one is aromatic, the other is a linear chain. That's not a influencing factor at the moment, So if the two R's are there, it's a sort of a secondary amine. If you have reacted it again with the Hinsberg reagent, as usual, let's say if the given compound to be the primary secondary amine, again, as I've explained to you, the sulfur is connected with 3 electronegative gentle leads, so they will produce a partial positive charge at it, giving a chance for the lone pair of the nitrogen to attack it, and at the same time nucleophilic substitution reaction, the chloride will be the leaving group. So what will be the next product? It will be a sort of a sulfonamide again, okay, but at this point of time the nitrogen won't carry any other proton at the moment. So once this bond is formed, and if we put in sodium hydroxide, this is a base, it has the ability to pull proton out. But at the moment it does not carry any proton, so it will not be able to pull anything out of it. So it will not be soluble in sodium hydroxide. What will happen resultantly? This sulfonamide, which has been generated from secondary amine, what is supposed to be about it? That it will precipitate out. It will settle down, it will settle down in the form of solid, in the form of precipitate, which means it is not soluble in hydroxide, means it does not carry one extra proton available for the solubilization, means the starting compound is a sort of secondary amine. So this is how you can compare. The number one was which was soluble in sodium hydroxide. Why it was soluble? Because one of the proton was available over there. Proton was available because it was a primary amine. Okay. In second case, the extra proton is not available here, and it cannot be abstracted by the hydroxyl group. So it won't be show any solubility, will settle down as precipitate, representing that the given compound is a sort of a secondary amine. Similarly, let me talk about the option number 3, the condition number 3. I would say that if you are given a sort of a tertiary amine, means where nitrogen already carries 3 R's, R1, R2, R3, one can go this way. So what's going to happen then? Let me make it a bit more clear. Again, sulfur, presence of again 3 substituents, 3 negatives around the sulfur creates partial positive, told you earlier, giving a chance for the lone pair to attack at this sulfur. As a result, it has to leave as a leaving group. Yes. Then what happens? We have R1, we have a nitrogen here, we have R2, we have R3, then it would have reacted to formed a bond with sulfur, oxygen, and then we will have a sort of aromatic ring. So at this point of time, as you know, the nitrogen is supposed to carry positive charge due to the excess valency. Then this positive is balanced by kicking out one of the proton available at nitrogens. But in this case, all are some sort of the substituents, some alkyl groups are there. So this nitrogen will not be able to kick out any of the alkyl to settle its positive charge. It is not possible because only protons are kicked out easily to settle the valencies, settle the positive charges. Once you don't have a positive protons, you have an alkyl groups around the center which is positive, then you can't really satisfy the positive charge. Then it means this nitrogen will not be able to attack at here and will not be able to produce this product, no product formation, no product. When when you're starting compound in some sort of a tertiary amine, mean all are alkyl substituents, they will not be able to undergo a nucleophilic substitution reaction with Hinsberg reagent. They will not be able to expel the chloro out. They won't be able to produce this sort of a sulfonamide product. So that will be clear that as this product hasn't been appeared in the test tube, which has to be solubilized in the sodium hydroxide on the next step, as it hasn't been formed, so you don't need to put in sodium hydroxide, so you don't need to put in sodium hydroxide. So if it hasn't been formed, means the given compound is a tertiary amine. It's not a secondary amine, it's not a primary amine. So this is the basic test. It's a pretty simple test, Hinsberg test. It helps you to identify the presence of amine, the nature of amine. The nature means whether it's a primary, it's a secondary, or a tertiary amines. I've told you earlier, the primary amines and secondary amine produces corresponding sulfonamides. In case of primary amine, this product sulfonamide carries one proton, which can be abstracted by this hydroxyl group, making it soluble, representing the given starting carries two protons, means it's a primary. If the compound compound reacts with Hinsberg reagent and forms a product, but that product does not undergo solubilization but turns out to be a precipitate, then it means it does not carry any protons, so it hasn't undergone a solubilization, so means that was a secondary amine. The third option, the amine is there but it never reacts with the Hinsberg reagent, means that amine, that gentle amine, is supposed to be a tertiary one. It's not a primary, it's not a secondary, it's a tertiary. So one can identify the presence of amines using Hinsberg test. This is how one can identify so easily, So this is Hinsberg test. Why we perform Hinsberg test? Just to identify compounds. Why we need to identify the different degrees of amines? As I've told you, if once you are trying to prepare an azodize, then you need to start with a primary amine. So if you want to start with a primary amine, you need to have an idea whether the given compound of primary, secondary, tertiary. You need to identify, so you can go for the Hinsberg test. Or sometimes in your lab activity, your instructor, your teacher asks you to identify the given amine. Then again you can use the Hinsberg test. You can apply this test for the identification of our proper response. Similarly, let's say if you are working in a lab, in an industrial lab, if we ask you the other way around, you're working in a lab in an institute, or you're working in a lab in an industry, we provide you, or you're instructed to give you two boxes, two boxes of the compounds, two packets of the compounds, and we ask you these two packets. One is of aniline, one is of diphenylamine, and we ask you to please specify the bottles, which one is of aniline, which one is of diphenylamine. Do you think so you can recognize those? Do you think so you can identify those given bottles, given packets, given compounds? Yes, it's very easy, as I've just discussed with you. As you can see at this compound, two protons are present. Aniline means it is a sort of a primary amine. In this case, you don't need to look around what are the substituents. Just look what is the situation with the nitrogen. How many protons are available? One proton is available means it's a sort of a secondary amine. So one is primary, one is secondary amines. Forget about the next rest of the structural identity, structural features. You can just focus on the nature of the amine, primary and secondary amine. Simply you can apply the Hinsberg test. As I've just explained the chemistry, this bud is supposed to be soluble. At the end, the sulfonamide will be produced from this gentleman, from this compound, that will be soluble in sodium hydroxide, and the sulfonamide which will be produced from this compound, that will not be soluble in sulfonamide, because this is one of the proton will be lost at the first step at the formation of sulfonamide. There won't be the availability of the proton number 2 that is required for the solubilization process. So it will not give a solubilization in sodium hydroxide, or this will be soluble. It's sulfonamide, corresponding sulfonamide generated from Hinsberg reagent will be soluble. So that will be very easy for you to identify two bottles. You can mark them. Okay, this one is of aniline, this one is of diphenyl amine. You can use this compound, you can use the bottle of this compound for the preparation of azure dyes. You can't use this compound diphenylamine for the preparation of azure dyes, because for the azure dyes you also need primary amines preparations. So this is how one can use your knowledge for the identification of amines. Why we use Hinsberg test? Let me just give you a little background of this test. Why we actually apply such tests. I've given you in my previous lectures an overview that once we give you unknown organic compound, we give you an unknown organic compound and we ask you to identify its nature. What is it? What you do, you take that unknown to you organic compound, and you start simply with the test number 1, which is called Litmus solution test. That is going to be the very first activity that you do in your lab. Litmus solution test. Once you perform that and your litmus solution suggests the given compound is an acid, then it means the acid could be only two things. The acid could be either it is a phenol or it's a carboxylic acid. It's a carboxylic acid. Two possibilities only. Once an unknown compound is given to you and you started off with litmus solution, and the litmus solution suggests the given compound is a sort of an acid, then two things should come to your mind. Either the given compound is phenol or it's a carboxylic acid. No other category at your level. Option number 2. If your litmus solution suggests the given compound is a base, it's not acid, it's a base. Litmus solution, suggests the acidic, basic, or neutral behaviors, neutral natures of the given compound. So if it suggests that the given compound is a basic, then it should come to your mind that the given compound could be an amine. It could be an amine. Similarly, if your litmus solution suggests the given unknown is a neutral entity, neutral compound, then it could be a carbonyl compound, or it could be carbohydrate. Two possibilities are there: carbonyl compounds, aldehyde ketones, or carbohydrates. So this is the three options which turns out to be as a result of litmus solution. So once your litmus solution suggests the given compound is an amine, then you can confirm them by using, yes, number one was you may use diazo, or I would say you should apply Hinsberg test, Hinsberg test. So using this Hinsberg, you can distinguish whether it's a primary amine or it's a secondary amine or it's a sort of a tertiary amine, as I've just explained in a very well detail. So you can find out the nature, exact chemistry of the given amines. That is why we need to apply Hinsberg test. That is the background. Once you want to know the nature of the given unknowns, the students are supposed to start with litmus solution. The litmus solution suggests the given compound is basic, fine. Then you can have a Hinsberg test. It will suggest the given basic compound is either primary amine, secondary, or tertiary amine. You can distinguish. Or if you don't have the availability of the Hinsberg test, you can use the carbyl amine test for the identification of an amines, or you can have an access to the reagents available which are required for the diazotization test. Then you can use the diazotization test. So amines basically can be identified by three tests: diazotization test, carbyl amine test, and Hinsberg test. Out of those, Hinsberg test is the test which actually separates them out from each other as well, primary, secondary, and tertiary. Hope you got hope you got the idea about the Hinsberg test, the chemistry, and how it helps you out. If you have any question, please don't hesitate to ask me. Thank you very much. Assalamu alaikum.